Welcome to another episode of Terry's Notes. And today I'm going to be looking at Charles' Law. Okay, so the first thing, you all need to be able to give a definition for Charles' Law, right? The volume of a fixed mass of gas is directly proportional to the absolute temperature, provided that the pressure is kept constant. Now, when given definitions in physics, you need to be very precise. So if we look at the definition, we are talking about the volume of a fixed mass of gas, right? So we are talking about volume, and we are saying that the volume is directly proportional. So you need to say directly proportional to the absolute temperature, right? Provided that the pressure is kept constant, right? So mathematically, what we are saying is that the volume of a gas is directly proportional to its absolute temperature, right? If we remove the proportional sign, this becomes V is equal to K multiplied by T, where K is a constant, right? You may also see Charles's law written as V1 over T1 is equal to V2 over T2, where V1 is your initial volume of a gas and T is the initial temperature of the gas in Kelvin, and V2 is the final volume of the gas and T2 is the final temperature of the gas in Kelvin. Now, let's look at how we came up with Charles's law. So, you also have to be able to describe an experiment to demonstrate Charles's law. And this is essentially the apparatus that you use. We have some air trapped in a column, right? There's a concentrated sulfuric acid plug at the top here. And this here represents the trapped air. So this is air. And we have a water bath, and we have a thermometer that is measuring the temperature of the water bath. So if you had to describe this experiment, you need to draw a simple diagram showing a column of air trapped by a concentrated sulfuric acid plug. You need to put this tube now in a water bath. We need a thermometer to measure the temperature of the water, and we also need a ruler to be able to measure the length of the air column, right? Now the volume of the air column will be equal to the cross-sectional area of the column multiplied by the length. But if we assume that we assume that the cross-sectional area of the column is constant, we can say that the volume is directly proportional to the length. So once we know the length, that gives us an idea about the volume of the air trapped in the tube. Okay? So like I said, you need to be able to draw the diagram, and you also need to be able to describe the experiment. So what you need to do is, at a particular temperature, you note the temperature, then you note the length of the air column. So you're going to have temperature in degrees Celsius, and we're going to have length in probably millimeter or centimeter, right? And what you're going to do is, for a given temperature, let's say at room temperature, which is 25 degrees Celsius roughly, we're going to record the length. So we're going to get something, let's say 2 millimeter. Then we're going to apply heat to the water. We're going to heat the entire container. The temperature of the water is going to increase. So at this new temperature, let's say 35 degrees C, we're going to measure the new length of the air column, right? Let's say we get 4 millimeter, right? So basically this is how we collect data from this experiment. And remember, with Charles's law, the pressure is kept constant. Well, the entire experiment is exposed to atmospheric pressure here at all the different temperatures. Therefore, the pressure is being kept constant, right? So let's look at some data. So what I've done here is simulated some data for this experiment, right? What I suggest you do is to pause the video and actually try to plot this graph using this data here. So we have length of air, the length of the air column, and we have temperature in degrees Celsius, right? So you can pause the video and draw the graph. Now this is what the graph is supposed to look like. All right, so we have length of air column on the vertical axis, right, or the y-axis. Make sure label the y-axis as length of air column, and make sure provide a unit. The unit in this case is millimeter. On the x-axis, we have temperature, and the unit is degrees Celsius. So when we plot the data, we get a straight line, right? So we know that we have a linear relationship. However, there's something very interesting about this graph, right? And I'm going to show you what happens in the second graph here. So what I've done here, using the same data, so the blue points represent the data that we are provided with. If I extrapolate this graph, when I say extrapolate, I extend the graph backwards until it cuts the temperature axis. So keep going back, and we're going to cut at this point here, right? Now this temperature is what we call absolute. This temperature is called absolute zero, right? And that is minus 273 degrees Celsius, right? So from this experiment, we know that if we extrapolate the graph until it cuts the temperature axis, it will cut at minus 273 degrees Celsius, all right? Now, it is because of this we can establish what is called the Kelvin scale of temperature, or the absolute scale. So let me show you what I mean. For the same data that we were provided with, we had length of air column, temperature in degrees Celsius, and what we are doing now is establishing the absolute scale. Now this is in degrees Celsius, and the absolute scale temperature is measured in Kelvin, right? And in order to convert degrees Celsius into Kelvin, all we add 273 degrees to the number. So let's say we have 2. So we have 2 degrees Celsius. If we want to convert that to Kelvin, what we have to do is to take 2 plus 273, and this will give us 275 Kelvin, right? Always remember, when we are using the gas laws, we work with temperatures in Kelvin only. Now, let's say we plot length of air column against temperature in Kelvin. This is what happens. Let's shift this graph a little bit. Okay, so what we have is a straight line that passes through the origin, but what is different with this graph is that we have used the Kelvin scale of temperature. Now, if you remember from maths, if we have a graph, we have y and we have x, and we have a straight line that passes through the origin, right? We see that y is directly proportional to x. So in this case here, if we look at the graph that we have plotted, we can say, now remember we are looking at length of air, and remember I said that length is directly proportional to volume, right? So we can say that volume is directly proportional to temperature, where temperature is in Kelvin, right? So what we get is V is equal to KT. All right, so this is essentially what we need to know. We need to be able to state what is Charles' law, which essentially says that the volume of a fixed mass of gas is directly proportional to its absolute temperature, provided that the pressure is kept constant. You also need to be able to describe the experiment by drawing a simple diagram, right? And this is also a typical data analysis question, typical question 1 in an examination, right? So make sure you understand the importance of the minus 273. The minus 273 degrees Celsius is really absolute zero. So from here, remember we said absolute zero is minus 273. So that temperature is what we define as 0 degrees Kelvin. Okay? So in another video, I will do some examples on how we use this law. Okay?